Hello everyone, कैसे हो सब? Today we are going to solve LeetCode problem number 994, rotten oranges. Let's see what's the problem is. The problem statement is like you are given an M into n grid where each cell can have one of three values, where 0 represents an empty cell, 1 represents a fresh orange, and 2 represents a rotten orange. Every minutes and fresh orange that is four directly adjacent to rotten orange become rotten. Okay. Uh, then return the minimum number of minutes that must elapse until no cell has a fresh orange. So basically, what's the problem is saying? Let's understand via diagram. So the question says we have given a grid like this, where two represents a rotten orange and one represents a fresh orange. So suppose we have given a grid like this. So the question is saying every minute, like the rotten orange can make four dimensionally connected fresh oranges a rotten orange. So what will be the minimum time in which all the fresh oranges become rotten oranges? So in this example, if we see, like what are the adjacent of these two? Like two represents a rotten orange and one represents fresh orange. Or zero means the cell is empty. So from here, like what are the adjacent of two? Two adjacent which are four directionally connected are this one and this one. So at the very first minute, what this two will make these fresh oranges a rotten orange. So the in first minute, like this will become a rotten orange and this will become a rotten orange. And in the next in the, in the next iteration, what will happen? This what are the like fresh oranges which are connected to this rotten orange? This one and this cell is empty. So in the second minute, this will make this as a rotten orange. So basically this become a rotten orange. And here also in the second minute, will become a rotten orange. So this is this have made it rotten orange. And in the third minute, like in second minute this happen, what will happen in third minute? There is no like fresh orange which are adjacently connected to it, and same for here. But for here the case is different. Like from here there is a one fresh orange which is directly connected to this. So in third minute, what will happen? This will become a rotten orange. In third minute, this will happen. In the fourth minute, this only left. This will become also rotten orange. In total, we have taken 4 minutes to rotten all the oranges. And the same example is given here, like in first minute, this and this has become rotten, and then this, and the answer comes out to be 4. So, like the nature of the problem is saying, like every minute we are like calculating for the adjacent elements and like going like adjacent to adjacent element like traveling from not this manner that we have make this and from this and they are left. We are like going from in order, label wise, like we are traversing. So by this uh, we can apply a BFS kind of algorithm here. Like basically we can apply BFS here to like solve this question, like because this is this is what's doing actually, like at very first minute it has scanned the first level, and in second minute, this third and fourth minute. This is going like level wise, so we can apply BFS here. So I have already like written the solution, like it can like code live to it can take very much time. So I have written already a solution here. So what I have did, I have basically made a queue here, like for BFS, and The data type which I have taken here is a tuple, which will store the row and column, and the time. This time represent at which time we have reached here. Then what we have did first we have iterated the whole matrix and store only those row and column with time zero which has a row and orange. Like suppose in this case we are at this 0 comma 0 row and 0 row and column both are 0 and orange which is placed here is row 10. So we have stored it in our like queue, and then we have started uh, BFS or BFS. So what we have did first, we have like get the element which is in our queue, and then we have taken off row, column, and time from that, and there is a global variable which will store the current time and the previous time, which will this queue contain. Basically, why we are storing the answer and the time which is max of this, because we only store those places in our queue which have like root and orange, so it will always be the answer that comes from this. So we what we have did here. So from current cell we can like traverse like there is already given we can traverse four directionally. So from here like if we do row plus one, so from here we can go here. From if we do column minus one, suppose we are standing here, so we can go here, and col plus one we can go from here to here. Then column minus one we can go from here to here. So these are the four calls which we have written here. And before making the call, what we are doing that we are checking the condition is the position we are going from the current position is valid or not. So if we are going from like current row to row plus one, then we will check this condition is valid. So let's see what this condition is valid. So first we will check that the position we are going is like outside of grid or not. So if we are going outside of the grid and that is not allowed in our case, so we will simply return false. And then we will check if we are like inside the grid, we will check the position we are going, it's like press orange or not. If the this is press orange, we will make it like rotten orange and return true that we are going at correct place. Either we will just return false. So what we are doing, we are updating our time to time plus one for every rotation noise from here like this. What was the value, initial value of this? This was 0. So if we are going from here to here, we are updating 0 plus 1 equal to 1. So the same we are doing here the value is 0, then here we are updating 0 plus 1 1. So the next call will have one value as well. So we are like calculating all the values, and then we check if there are any like cell which is uh, left as no rotten like fresh, then we will return simply minus one, as because we were not able to make all orange rotten. That was our ultimate goal. So this was the solution. I hope you will like. Oh, and all the suggestions are welcome. Thank you.